Hello, my lovely physical science class. Today we're going to learn about balancing our chemical equations. You should have your paper out that I gave you. So I'm going to be doing a guided notes. So you're going to start with the balancing equations, and as we go through these notes, you're going to be filling in your worksheet. So the first thing, a balanced equation is atoms can't be created or destroyed. So we realized this when we talked about Antoine Lavoisier. I can't say his name. Lavoisier. He had the law of conservation of mass. All the atoms we start with must be the same ones we end up with. So we can't create new elements by putting things together. We can only rearrange what we have. Think of Legos. If you start with a certain amount of Legos, you can't add a new Lego to the system or make a new Lego. All you can do is rearrange them. So a balanced equation has the same number of each element on both sides of the equation. So what I mean by that is the arrow. The arrow is going to show you what's on the left side and what's on the right side of that arrow. They need to be equal to each other. So let's say we had this example and we did a picture up here. So pictorially then, this carbon is joined with two oxygens. Notice then in our products there's one carbon and two oxygens. So that is a C plus O2 plus CO2. So this equation is already balanced. We don't have to do anything to it. There's nothing really necessarily to add. But a lot of times equations aren't. So what do we do if it isn't already balanced? That's where we have to come into play and balance the equation. So let's say that carbon joined with oxygen and only made the structure over here with one C and one O. So it can join differently. So our chemical equation looks like this one. We have a carbon, we have two oxygens, those are on the left side of our arrow, but on the right side we only have one C and one O. So as written, it almost looks like we've lost an oxygen. But we can't lose things during a chemical reaction. We have to show what might have happened. So we need to essentially add one more oxygen in the products. Well, how do we do that? So we can't change the formula. I can't make this formula here say CO2 because now I'm describing something completely different. What I can do, instead of adding numbers in the formula, I can actually add numbers out front. So notice how now my picture has changed. I still have my one carbon, two oxygens, but now look over here. I have two oxygens. So essentially what I've done is I've made two separate compounds. So what we must do is essentially make another CO so that it's balanced. But where did the other C come from then? So when balancing equations, think about making a peanut butter and jelly sandwich. You need two pieces of bread, you need jelly, you need peanut butter. Okay, well what if now all of a sudden you have to make your friend a peanut butter and jelly sandwich? You're going to add more bread to the picture, more jelly, more peanut butter. That's essentially what we did here. All we did is go, okay, I need two carbons to go with these two oxygens to make two different molecules of C and O. So in this case, we must have started with two carbons. So our balanced chemical equation looks like this. We have two carbons plus oxygen will yield two carbon monoxides. So let's go over some rules for balancing our equations. So number one, we have to write the correct formulas for all our reactants and products. Sometimes I might give you the formula, and sometimes I might give you the reaction in words. So this is where our naming rules come into play, the thing we just got done doing. Yes, we still have to know those polyatomics, so don't forget those. Number two, we're going to count the number of atoms of each type appearing on both sides. So we've done this before. We've looked at compounds and counted the number of atoms on both sides. Step 3, we're going to balance the elements one at a time by adding coefficients. What I mean by coefficients is those are the numbers in front. So I can only add numbers in front of my chemical equations. I can't put anything behind it or in between any of those symbols. So step 4 is just check to make sure it's all balanced. Sounds easy enough. So these are things we should never do when balancing equations. First one, never ever change a subscript to balance an equation. What I mean by subscript, we don't want to write any little numbers after our chemical formula. Little numbers are a no-no. So no subscripts. So if you change the formula by adding a subscript, you are describing a completely different reaction. So it's not the same thing by adding a little number afterwards. We have to only add the numbers at the beginning. So just an example, H2O is water, is very different compound than hydrogen peroxide. You ever have that stuff in a brown bottle you put on your cuts and it bubbles up, burns sometimes? That's hydrogen peroxide. If you drink it as if it was water, you're gonna die. So definitely a hugely, vastly different compound by adding just a tiny little 2 after that oxygen. And also, we never put a coefficient or a number in the middle of a formula. We can put a 2 out front of our NaCl, that's okay. But putting a 2 in the middle, we're not going to do that, because now that's not even anything. That's just a random 2 in the middle of a formula. So these are things we do not want to do when trying to balance an equation. So first of all, let's do an easy example. So this one should be in your notes. So go ahead and write down the example. So H2 plus O2 yields H2O. First thing we want to do is make a table to keep track of where you're at. So first thing, I use an R for reactants and a P for products. So remember, reactants are on the left side of my arrow. My product is on the right side. So I like to set up my equation the same way. So in this case, I have 2 hydrogens, so I'm going to put a 2 down. I have 2 oxygens. The other side, I have 2 hydrogens, put my 2, and I have 1 oxygen, so I put the 1. So if I look as is, my hydrogens are balanced, but my oxygens are not. I need twice as much O in the product. So what can we do? Hopefully you said we need to add some kind of number out front. So let's say we put a 2 in front of the H2O. So now let's see, that changes the O's. Because think of this as math. We're going to distribute that 2. So in this case, it changes my oxygen, so that 2 gets distributed. I now have 2 O's, but it's also going to change my hydrogen as well. So whatever number I add out front changes the number of the whole compound. So now I take 2 times 2 to give me my 4 hydrogen. I still need now I need twice as much H in the reactants as what I started with. So let's look at our reaction and see, can we add a number in front of our reactant that has hydrogen in it to somehow make it have 4 hydrogen now. Remember, I can't change the little number. I can only put a number out front. So let's try a 2, and let's recount. Every time we add a coefficient out front, we need to recount and see, are we balanced? So now we go 2 times 2. We're going to cross off our 2, and now we're going to put the 4 down. Oops, let me go back a step. So the equation is balanced. It has the same number of atoms on each side. Notice I didn't have to add a number in front of oxygen. That is completely okay. You do not have to add numbers to everything. You only need to put them where you need things to be balanced. So The answer is this up here in the yellow circle. This is your answer. What we did down here in our table, this is just the work to go about getting the answer. So if I ask you to balance an equation, yes, you're going to need a table, but your final answer should just be the chemical formula with the coefficients out front. All right, so we got a couple examples then. So these examples then, I'd like you to try this. We're going to work on some more examples in class, and we'll see how they go. So we'll start off with these examples tomorrow, and we'll go through them. We'll see if you got lost on anything, and we'll take it from there. So if you need to review anything, you can always watch this video again, but we are going to work on these balancing equations in class tomorrow. So see you guys then. Have a good night. Bye-bye.